so first thing we're gonna do is make a cube. Woohoo, this is how you do everything. And again, stop me at any point where like something doesn't make sense. Made a cube, makes sense? Cool. Press play, not much happens. Right? It's just a freaking cube. Ooh, okay, it's a cube. Alright, so this cube, as you notice, is like way out here. Do you know how to reset it to 0? So you can go here and transform right, and you can right click, and then there should be a reset position, and it'll go to 0, 0, 0. So you know the game window, whatever. Alright, so everything's at 0. HoloLens, super important, obviously. Other thing you can do you know about dragging? Like you can go here and drag. Yeah, so you can go here, drag like this. So you can go like this. Say you want to drag by 1 unit, you can hold control or freaking muffin. There's one button on here where you should be able to like alt drag or something, and it moves by 1 unit, whatever. Oh, right here. You drag the arrow instead. Sorry. So you hold control and you drag the arrow, move by 1 unit. Really good for 2D games when you have like tiles. So those are 2 things, or a couple things you should definitely know. Saves yourself a lot of time. Did you know? I'm gonna say did you know a lot, by the way, so get used to it. So if I added something in the scene right now, like I drop this back 2 units or 3 units, right, in the game, whatever's further back. If I unhit play, what happens?
Go back to where it was started.
Yeah, okay, so you do know that everything resets, right? Okay, cool. Good to know. Do you know how to, like, if you made a change in there, do you know how to, like, make it persist? Okay, so to make it persist, it's kind of a jank solution, but it does work. So you can go into scene here, pull something back, and, alright, so we know that. Let's just copy this component, or copy that game object, and then we can delete it, and then paste. Now we're back 3. So, and you can highlight like the whole scene. The thing that some people do, apparently, I've never done this, you can highlight like the whole scene by clicking, holding shift, clicking, copy the whole thing during the game, and then delete the whole entire scene, reset it back up. So, just some really quick helpful stuff. You can edit multiple things at once. I don't know if you knew that. So if you want to edit the transform of both these cubes at once, do you know how to do that?
I assume it's like both of them.
Yeah, so you can press control or shift or whatever. Like if you want them at the same spot or you want them at the same scale, right? So you can select them with either holding shift across them, or you can do this. And what you'll notice is if you do like a different type of object, like a plane or something, and you select all like that and that, it'll only have the components that are the same. Right, so there you go. Cool. That's kind of a whatever, but also another really helpful thing when you're trying to edit multiple things. Another thing you can do is called a coroutine. So we're gonna add a script, move forward. That's for delete because I want to remember to delete this later. Create an ad, it's going to take forever. Any questions so far?
Why are you scripts so far?
Because it's a Microsoft.
Seriously? I didn't know that.
Yeah, I don't know if Unity is Microsoft built, but it's built on C#. So it's actually C# that compiles down to C++ assembly, I'm pretty sure. I don't remember, whatever. So this is attached to the game object. Cool. Or it should be attached. That's when you go back here and you realize it just didn't attach it. I don't know, sometimes it does that. Oh, and now it refreshes. Cool. Remove component. Alright, so on here, let's say we wanted this transform to move forward, whatever, a unit after like one second, right? So first, I'm going to get the input. If input, this is just what I do for debugging. In general, I showed you this yesterday. Key down, key code dot alpha 1 now we can just call functions and like test stuff and do whatever. So I'm gonna say void move cube. There we go. All right. We'll input it. Okay, and we're just gonna call move cube. Makes sense? Any questions? Okay. And like I said, I have no idea what you do, don't know, so stop me at any point. And how would I move the cube 1 unit, like forward in the Z direction?
Just add dotted line to this anything else.
How would I do
We'll
that?
get the game object first, right?
All right. So how do I get the game object?
So how I do it is I create a variable, like a game object variable in the global space.
In the global space here,
No.
or inside the class?
Inside the class.
Okay, so a member of the class.
Member of class, sorry.
Okay, yeah. It feels very global. In Unity, it's kind
Yeah.
of that's kind of what it's built for. But yeah. So you do something like game object, whatever, like this object, right? Like the thing it's on, right? Okay. You don't need to do that.
Okay.
Too much work. Let's be lazy. And what you can do, if you want the actual game object itself, if you just type in game object,
That fun.
no, you have the game object.
Oh, so it's like because I'm attached to the script.
Yes. So if you just type in game object, you get the game object that you're on right now. So if I did debug.log game object, all of them, by the way, have a dot name. So I can do this, I can press play. We're gonna ignore the HoloLens broken whatever assembly. Come on, I believe in you. Okay, and which it was 1, right? Yeah. So cube. Cool. So you don't need to actually store the game object. It's on the game object. It knows what game object it's on. With that being known, if you ever see this, like, is it arrow game object or something? Whatever. Or in a tutorial, if you ever see this dot game object, you're C++, right? So this is what? Do you know what this is or not really?
It's the class itself.
Yeah, it's the class itself. So should you ever be writing this inside your program?
Should you?
Yeah.
I'm not sure.
Okay. So very, very rarely, something like called a copy constructor. You probably learned it at one point and forgot about it because most people do. You almost never use the word this, or else everything would be like this dot transform, this dot, this, right? And it's very redundant. So if you just type in game object, the this is already there.
Yeah.
So you might see in some tutorials, which I've seen here and there, like say this dot, don't write this. Just don't do it. It's bad form. Right. So it's not like it'll break your program at all. It's just bad form in general. In programming in general, you should almost never be using this unless you need to, like absolutely need to, which sometimes you do. So instead, we can just write game object, or we want to move the object. So what do we want? We want its what? Not its coordinate. Yeah, its coordinate. So what component do we want?
Well, what direction are we moving inside?
It doesn't matter what direction we're moving. How would we move a game object? What's one way you can do it? There's a couple ways to do it. Yeah, so we can alter its position. How do you get its position?
I do game object transform that position.
Okay, game object transform that position. Also, if you just do transform,
Yeah.
it's a game object's transform.
Because it's a
Yeah, and every game object has to have a transform, so you can just assume the transform is there. Dot position equals.
I know this works and everything, but is this like good coding standards? Because it's like, what if someone, a future developer comes in and looks at this and he's like, he's never worked in C#, he's like, what the hell is going on?
Well, if they've never worked in C#, you probably wouldn't hire them to do Unity development.
Okay, no, fair enough.
As long as you're consistent, and I will tell you, I'll look at the code you do, and I'll tell you like, I don't like this, I don't like this, I don't like this. Change it to this, 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 and that's how companies work, right? Like you've worked at a company, you know that like it's all about consistency of the coding standards of that company, like down to the bracket. I was telling the high schoolers I worked in C# over a summer, and you'll see actually most C# is written like this with the bracket over here. I just don't really like it, so my autosave like formats my stuff. But they had a linter. Do you know what a linter is or no? So a linter essentially goes through your code and like looks for like style issues and a couple other issues, and it'll like basically yell at like tell you all these issues. Normally a linter will just be a bunch of warnings. You run your thing and it's like, warning, your bracket's up here, but it doesn't affect your code in the long run. At the company, they literally had something that would not, they turned the linter on and then told anything that was a problem to be a error, like a compile error. So you had to have your code linted out nicely. So basically, long story short, you do what the company wants.
Yeah.
So as long as you understand consistency and feedback, then who cares? There are some things in general, like this, like typing in this, is generally accepted as poor form in C++, and I'm pretty sure C#. I'm going for my C++ like understanding. All right, so transform.position equals what? We're just moving it forward. It doesn't matter. I don't care if it's X, Y, Z.
You can to operator directly +1.
Yeah, so you can't do like equal +1, right? So this is actually like quote unquote a read only, but it's not. So you can do this, and you have to say equals some sort of vector. You could do like vector 3.0 if you wanted to, and like let's say we just want to move this cube back to 0. We do transform position equals vector 3.0. So when I do this and I hit play and I hit 1, we'll see it in debug whenever cube, because I haven't gotten rid of that, I don't think. Come on. And there you go. Now it's transforms at 0. Super exciting. Not really. All right. Well, while you do that, I'm just going to commentate over this as if you were here, and you can watch it later. All right, so how we move forward? All right, so how you move forward is you go transform dot position, so get the current position you have, plus a vector 3, because you have to add a vector 3 to it, and we're just going to go 1 in the Z direction, and the Y direction. How about that? There we go. And it has to be a new vector 3. Cool. So when we do this and we hit play, you'll see that it will just move in a diagonal, but you'll notice it moves like very fast, like it instantly sets it. So there you go, it goes up and back. Ooh. So we're going to make that look nice, and we're going to use something called a coroutine and lerping to do that. Lerping stands for linear interpolation. So we're actually going to turn this into a coroutine, which is essentially a function that feels kind of like a parallel function. Perfect. Came here right just the right time. All right, so we're going to do a coroutine. So the way you do that is you start coroutine. This is how you move it, by the way, Trent. You have to add a vector 3. Yeah. So when you do start coroutine, and you literally pass in the function like this. If it has arguments, you just pass it in like this, and you'll notice this will yell at you and say, like, whatever, it needs a coroutine, blah blah blah. So a coroutine returns an I enumerator, not void. Yeah, so I enumerator. So it allows you to yield return. Add what? System.collections.
Oh.
Yeah, it's in system.collections. Was that your question? Sorry.
No, my question was like
inherit this I enumerator? No, it's from system.collections. Yeah. Okay, cool. So you see this yell at me, now code pass return a value, whatever. So we're going to move the cube, and just to show you, well, whatever. Basically the cube just instantly teleports, right? Yes. And we don't want it to instantly teleport. We want it to look kind of nice. So we're going to say we have a vector 3 start position equals transform dot position, and then we're going to do vector 3. Oh, look at this. We can just use this. This is our like goal position, right? Vector 3 goal. Oh my goodness, caps lock. Goal position. Cool. So this is our start position, this is our end position. We're going to move it periodically over time, like a certain amount. Like at this time, we're going to move it a little bit. So how we're going to do that, I'm just going to write it all out and it makes a lot more sense. Time elapsed equals 0, f, float, total, lerp, time. Best part is that's going to be in the video. So we're gonna do this over 2 seconds. So while time elapsed less than total lerp time, we're gonna say transform dot position equals vector 3 dot lerp start position end or goal what did I call it, goal position, and then time elapsed. I'm gonna use this in fences. Time elapsed divided by total lerp time. All right, and then we're gonna do. So you have to yield return. You can look up what this actually means, but we can yield return new, wait for end of frame, wait for this many seconds before you start the while loop again. Basically, all of these are wait and don't go back to this loop again and like look up here until something happens, like for a certain amount of time until something happens. So we can wait for the end of frame. You can come in. I'm just showing him what coroutines are so you can learn too. So we can wait for the end of the frame, and then what happens is after every frame it'll come back to this while loop and check this while condition, do this, and then go back to this yield return, and this function will keep running constantly until this while loop's done. Right?
Yeah.
So right now it's an infinite while loop. What we need is time elapsed plus equals time dot delta time. So this is the time between each frame. So how much time has passed since the last frame. So now what you'll see, and I'll go over what all these arguments are. I'm going to show you what it actually does first. So if I play, and I hit 1, oh my goodness. No, obviously not. That's not what we wanted. Let me see here. Start position equals transform dot position, new vector 3, goal position, this looks fine. Start coroutine, debug dot log. Maybe I just didn't save it or something. I don't actually know. Okay, so let's make sure. Yeah, so that's good. That all recompiled, that's why. Okay. Maybe that my while loop different, and you're gonna look on the. There we go. So see how it like goes that way. Yeah. So and you'll see runs. So essentially, what happens when I hit 1, right? It starts the coroutine, goes down here, evaluates all this code, so it moves it to. I'm gonna explain what lerp is, and then just time and then waits for the next frame, and then runs this again. And this feels like it runs in parallel, but it doesn't really. It actually runs after all the update functions, I think. I don't remember. Like, all the update functions run, then this runs. But if you said, like, wait for 20 seconds, this won't run for 20 seconds. Like, Unity won't call this again for another 20 seconds. So, I'm going to say what this vector.lerp does. So, it takes in 3 arguments. The first argument is, like, what is the first vector 3? Which is typically your starting position. So like, where's the thing starting? What's your goal position? And then this, you want to guess what this is? The argument needs to be between 0 and 1. It's a percentage of, what do you think the percentage is?
How much it's going to be?
Kind of. So time elapsed divided by total lerp time, right? When this is 0.5, how much time has passed? 50% of the time, right?
Oh, sorry, I heard 0.0.
Yeah. So 50%. And where would we like our cube to be when 1 second has passed.
Again, position.
Do we want it at our end position? When do we want it? Well, when do we want it at our end position? When do we want it at our start position? At time 0, right?
Yeah.
So when do we want it at our goal position?
Whatever time we set it as, our total time.
Yeah, total time, right? 2 seconds.
Oh, so it would be 1 second we want it halfway.
Yeah, at 1 second or 50%, we want it halfway.
Got it.
So what do you think Lerp does?
I assume it does what we just said. Like it takes that. So starting position, end position, that's our rank for the vector, and then that percentage that's coming out of that is like it's going to be in between those, so it's going to base the position between those.
Yep. So it does linear interpolation.
There you go.
Yep. Perfect. So it will go like 50% between these two and return a vector that's 50% between the two. And then you wait for the next frame and it gives you now like 52%.
Yeah.
So that's why you get this like movement. And you'll notice the movement will all be linear. So like when I hit play, because it's a perfectly like linear animation curve to do this. Oh my goodness. And I hit 1. Oh my, there we go. You'll notice it's like a nice linear movement. Now we can get all types of movements. So the one I just did is a more quadratic movement. So we can do is talk about, let's see here, blah 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 blah. We can do time elapsed, race to the second. Can you race flows to the second? Yeah, you can. Let's see. Or do you have to multiply by itself? Ugh. Time lapse. Time lapse. There you go. And then total time elapse. Times total time. Oh, total time. Yeah. Oh my goodness. There we go. Okay. So percentage wise, how do you expect the cube to move? Like say we're at 1 second, right? Is this gonna move? How do you think this is gonna move? What kind of curve does this look like?
Exponential.
Yeah, some form of exponentially,
Yeah,
well,
so
quadratic
it'd be
kind of.
quadratic.
Yeah, so it's to the power of 2.
So it'd be like, no.
Yeah, is it gonna go
Yeah,
fast
what's
first
wrong?
or slow first?
Slow first, and then it's going to be
Alright, well now
it's exponential.
So this is where you start getting into animation curves, and you can like manually make these animation curves. But oh my goodness. Ooh. Yeah, so it's slow and then fast.
Yeah, okay. Mathematics, yes.
Yes.
Okay.
So how would you go the opposite way? This is the last thing I'm going to cover.
Inverse?
So I thought that at first too. I literally just did this today.
Okay. Oh, wait.
Zhang Hao, you may also chime in. How would you do the opposite?
Wait.
So fast and slow.
Wait. Just the you have the close node and you supposed to minus the thing on the
Total minus the thing.
Oh, that would be the reverse.
Yeah, that would go reverse direction. Great check. That would be like 100% right. So be the goal position and then move backwards. Yeah.
So you want to go fast first, right?
I wanted to go fast first. How would you make it go fast first? Once I tell you the answer, you're gonna be like, I hate you. Because I try to like do like an invert, like 1 over, and I try to like square stuff, and it's really not that complicated.
You just
It's one math function divided by another math function.
Oh, you're dividing it here?
Yeah. There is a division involved because it has to be a percentage. So it has to be 0 to 1.
I'd assume it'd be you can negate it, don't you?
No, you don't negate it because the answer has to be 0 to 1, right?
Right.
I can write it in whenever you want. The two, you will be using time elapsed and you will be using total Lerp time. Because it has to be a percentage. One is a percentage of the other.
Yeah.
So this is how you made it go from slow to fast, right? Yes. So this is slow to fast. How do you get the opposite curve?
Oh, okay. Can you use like cosine?
You can use a cosine. So you can get a cosine curve and you get some cool stuff with cosine, but no, that is not the answer.
I thought the opposite curve would be
Cosine and sine and all that, so good things to like mess with and get animation curves for. They're actually, cosine and sine are like naturalistic like curves. So like jumping in games, when you make a sine curve to your jump, people love it. Or you make like your acceleration is like a sine curve. People really like that. one of the guys at Michigan actually spent like a ton of time like mapping out this jump. He really felt really good, and he like put all these timings down frame by frame.
Oh, I know.
You know the answer?
I think
Once you know the answer, you'll know the answer.
I think like I'm not really sure.
Okay, you gotta. Nope.
Minus time lapse.
Okay. 1 minus.
Time.
Okay, you want 1.
Oh no, that's the. Yeah, I think so.
You want what? 1 minus time elapsed?
Yeah, and
then what do you want over here?
oh, like
It doesn't matter. It's 2 seconds, so none of that helps.
oh my
Okay,
God.
do you want me to just give you the answer?
No.
I'd like to try to figure it out.
Okay, I can stop the video here, and then y'all can figure out the answer.
Oh my.
But it's just a mathematical.
Do you have any questions, by the way, that can then be recorded on the video that you'd like?
No, I think
Okay, so yeah, this was coroutines and stuff like that.
it's